this video, we're going to discuss voltage and current unbalance and how to calculate it. This calculation is very important to ensure the long life of an electric motor. Voltage unbalance of more than 2% can cause motors to overheat and fail. Let's look at the recommended method for determining voltage unbalance. In this example, we have a three-phase motor that is 240 volts. By taking voltage readings on A, B, and C, we find that between A and B we have 243 volts. Between B and C we have 236 volts. And between A and C we have 238 volts. We can find our average voltage by adding our three legs together and dividing by 3. In our example, we had 243, 236, and 238. That adds up to 717 volts. Divided by 3 gives us an average voltage of 239 volts. In this example, the amount of phase unbalance is satisfactory as it is below the maximum allowable of 2%. To determine this, we took our average voltage and subtracted it from our actual voltage, and we found that our maximum deviation in our voltage is 4 volts. To determine the percentage of voltage unbalance, we take that number times 100 divided by 239, and we come to a 1.7%. Any unbalance over 2%, you would need to find out where your problem is in your electrical supply. The other thing you need to look at is the current unbalance, which you can have a maximum of 10%. Voltage unbalance will cause a current unbalance, but a current unbalance does not necessarily mean that a voltage unbalance exists. A loose terminal connection or a buildup of dirt or carbon on one set of contacts, using the example of L1 as the problem leg, would cause a higher resistance on that leg, L1, than on L2 and L3. The current follows the path of least resistance, so the current increases in legs 2 and 3. Higher current causes more heat to be generated in the motor windings. The percent of current unbalance is calculated in the same way as voltage unbalance, with a maximum acceptable current unbalance of 10%. Most compressor and unit startup sheets have a place to record voltage and current on compressors and motors. These readings should be taken at startup and during regular maintenance. The long life of equipment is dependent on keeping these two values within their normal parameters. If you enjoyed this video, click the like button and subscribe to this channel to make sure you don't miss new videos each week. Thank you for supporting this channel.